right, so now we're going to talk about synthetic division. You can only use synthetic division when you have linear divisors. So your x of your divisor has to be to the first power, x to the first power. Long division will always work. Synthetic division only works when you have a divisor of degree 1. Okay, so the first example, I have a lead coefficient of 2. And so when you have a lead coefficient, the way that there's more than one way to do this. The way that I do it and I teach to do it is the first thing you want to do is get rid of anything in front of the x. If there's a number there, you want to make it go away. How would you cancel that out? You would divide by 2. When we do that, we can't just divide the divisor, right? That would change, it changes stuff. So if we're going to divide, we have to divide everything by 2, just to keep everything balanced. And if I do that, then I'm just going to divide the coefficients by 2. 10x to the third divided by 2 would give me a 5. X to the third. 13 does not divide by 2. It's okay. I'm going to write it as a fraction. I know you're like, oh my gosh, this is going to be a disgusting fraction. Just trust me. It's not that bad. It all will take care of itself. So minus 13 over 2 x squared plus, well, 5 doesn't divide by 2 either, so I'm going to write it just as 5 over 2. And that's an x minus 14 does divide by 2, that's 7, so just 7 divided by my new divisor. So now I have 2x divided by 2 is just x, and minus 3 over 2. So yes, everything else became a fraction, but my lead coefficient of the divisor is now 1, and that's what I want. That's more important. When you do synthetic division, or when you do long division, you divide by the factor, right? Before it was like x plus 3, the 2x minus 3. This one down here, the x plus 2. When you do synthetic division, you're not dividing by the factor, you're going to divide by the 0. So you have to take this to the side, x minus 3/2 equal to 0, so x equals negative 3/2. So we're going to divide by the 0, the negative 3/2.
Wouldn't it be positive?
Yes, it would. Thank you. Add 3/2 to both sides. It does become positive. That's positive 3/2. Very important to get that right. All right, so you take your 0, 3/2, and you put it over here on the side. 3/2. And then I'm going to make an upside down division sign. Just take this, make it upside down. Just leave plenty of, make some extra space there. And then from my dividend, from what I'm dividing, I'm only going to take the lead coefficients. So the 5, well, also you need to make sure you have all your powers of x. X to the third power, x to the second power, x to the first power, x to the 0 power. All the powers of x are there. That's important. Then just take the coefficients. So 5. Negative 13 over 2. I'm just going to write negative 13 over 2. Positive 5 over 2. So 5 over 2. If you want to write positive, it's fine. And negative 7. So I just took the coefficients, the lead coefficients. Not lead, but just the coefficients. Every time you do synthetic division, you start the same way. You just take your first number and bring it straight down. Don't do anything to it. Write it below the line, 5. Then you multiply, whatever's below the line gets multiplied by your 0. So 5 times 3/2. When you multiply straight across the top, straight across the bottom. You don't need a common denominator. So we have 3 times 5 is 15 over 2. This is positive. So positive 15 over 2. And then you always add everything above the line. You're adding the columns. So I have negative 13 over 2 plus 15 over 2. Well, they have a common denominator already. I told you the fractions will work themselves out. So you're not really worried about that. So you have negative 13 plus 15. So that's positive 2. And the denominator is 2. So it's 2 over 2. 2 over 2 is just 1. So 1. Then you have 1 times 3 halves. That's positive 3 halves. Again, you have a common denominator. So you look at the numerators. 5 plus 3 is 8. 8 over 2, that's 4. 4 times 3 halves. 4 times 3 is 12. 12 over 2 is 6. It's a positive 6. Negative 7 plus 6. It's negative 1. Negative 13 over 2 plus 15 over 2, that's positive 2 over 2. 2 over 2 is 1.
Oh, okay. I don't know why it's supposed to.
When you do synthetic division, your last value is your remainder, so put it in a box. And now I can write my answer, or my answer from the division. It equals, I'm going to start with writing with the 5. Since I started with x to the third power, the lead term is going to be 1 less than that. So I'm going to start x squared. So this is a 5x squared plus the 1 is x, so plus x, plus 4, plus the remainder over divisor, negative 1 over what you divided by, and not the 0, but the actual divisor that you started with, 2x minus 3. So that's the answer from the division, but if we're writing all the factors, that means we also need to write times 2x minus 3. Just like we did with the long division, we have to include that. So this divisor is always below the remainder, and it's one of the factors. So we did deal with some fractions, but they ended up taking care of themselves, yes.
Why is the 5 getting x squared?
Because we started with x to the third, and when you do synthetic division, you always just, when you start writing the answer, the quotient, you start with 1 less power than what you started with. All right, so that's the complicated synthetic division, is whenever you have a lead coefficient that is not 1. All right, so then let's look at this next one. B. 2x to the fourth minus 5x squared plus 5x minus 2 divided by x plus 2. All right, this time our divisor is a 1x, so that's nice. We don't have to deal with those fractions again. But remember, you take the divisor, x plus 2, set it equal to 0, so x equals negative 2. So the factor is x plus 2, but when we do synthetic division, we divide by the 0, and the 0 is negative 2. So we're going to put negative 2 in our box, or on the outside of the box. Set up the upside down division. And then before you start writing your coefficients, make sure you have all of the powers of x. I have x to the fourth power, then I have x to the second power. I'm missing x to the third power. So I'm going to put a little note, plus 0x to the third power. It's not there, so I need a placeholder. You have to use a placeholder. So x to the fourth, x to the third, x squared, x to the first, x to the 0. Okay, that was the only one that was missing. Then you take the coefficients, write them in order. So 2, 0, negative 5, positive 5, negative 2. And then you can start your synthetic division process. Bring down the 2. 2 times negative 2, that's negative 4. 0 minus 4 is negative 4. Negative 4 times negative 2, positive 8. Then add. Negative 5 plus 8 is 3. 3 times negative 2 is negative 6. 5 minus 6 is negative 1. Negative 1 times negative 2 is positive 2. And negative 2 plus 2 is 0. The last number is always the remainder, so I put it in a box. Okay, so then I'm going to take what I got from my division and I'm going to write it, my polynomial in factored form. So I have this 2. I started with x to the 4th power, so now this 2 is going to be x to the 3rd power. So I have 2x to the 3rd minus 4x squared plus 3x minus 1. That's in parentheses because the remainder is 0, so I don't have to include the plus remainder over divisor. And then don't forget about the divisor, x plus 2. And again, I'm going to highlight that because don't forget to put the divisor there. All right, so just 2 more little notes. Part 3 is the remainder theorem. So if you're just asked what is the remainder when you divide this polynomial by x plus 3, you don't have to actually do the division to find out what the remainder is. The remainder theorem says that if you evaluate the function at that 0, its value is the remainder. So what I'm saying, if I take the polynomial that I'm dividing and I write it as f of x equals just this numerator, x to the 4th minus 10x squared minus 2x plus 4, and I'm going to evaluate it. So if I'm going to evaluate a function, I'm going to write it with blank parentheses. And I'm doing this before I even find out what the 0 is, so I'm not tempted to not put the parentheses because I know a lot of you do that. So to the 4th minus 10 blank squared minus 2 times blank plus 4. So if I evaluate this function at the 0 that I'm going to divide by, then what I get is the remainder. So I need to know what the 0 is. So x plus 3. X plus 3 equal to 0. X equals negative 3. So if I evaluate this function at negative 3, it will tell me what the remainder is if I divide without actually having to divide. So all this on the right hand side, I plug it into the calculator. So I get f of negative 3 equals, and I type all this in with all the correct negative signs and the parentheses in all the right spots, and it tells me f of negative 3 is 1. So that means that the remainder equals 1. And I didn't have to actually divide it to find out what the remainder is. So if you're just asked for the remainder, evaluate it at that point. I could do synthetic division to check it. You don't have to do this part on like your assignment, but to prove it, I'm going to prove it to you. I'm going to real quickly do synthetic division. I put my negative 3 on the outside. Take my coefficients, 1, 0, negative 10, negative 2, negative 4. Bring down the 1. Multiply. gives me a negative 3. Add is negative 3. Multiply is positive 9. Add is negative 1. Multiply is positive 4. Nope. Multiply is positive 3. So that happens when I do it fast, huh? That's a 3. 3 times 1 is 3. Plus 3. So that gives me a 1. That gives me a negative. Oh, I wrote negative. That's where I messed up. Positive 4. Negative 3. And it leaves me a 1. So it gave me a remainder of 1. Just like I found over here, remainder of 1. So I just proved it, that both methods would work. But that one was easier. But the remainder theorem makes it easier. And then a little add-on to the remainder theorem is part 4, the factor theorem. So if instead of the question saying what is the remainder of this division problem, what if it asks, is x plus 3 a factor of that polynomial? Well, you could also evaluate it at negative 3, and if the remainder is anything other than 0, it is not a factor. If the remainder is 0, then it is a factor. So if the instructions say verify it as a factor, take the 0, plug it into the function, and if it equals 0, then you verified that it is a 0. That's why I don't have an example. There's not really much to show on that one. And then here's your assignment. You're welcome to do number 51 if you wish, but it is not required. It is an honors question.